Welcome back to Geometry 2.1, 2.2, Conditional Statements and Deductive Reasoning. So in the past, we focused on inductive reasoning and reasoning that's based on observing a pattern. And with inductive reasoning, anytime we reach our conclusion, that was called a conjecture. So if you recall, do you remember we had the problem where it said, let's go like Monday, Tuesday, Wednesday, Thursday, and then it said dot, dot. And we would feel, since we're going to reason by observing this pattern, it looks like our conjecture or the rule would be days of the week, right? And so the days of the week in order would go Monday, Tuesday, Wednesday, Thursday, Friday, and then Saturday. And so again, this is reasoning by observing a pattern called inductive reasoning. Well, today we move past inductive reasoning and we're going to focus on deductive reasoning. So everything that we do all the way down, C, D, E, all the way down to the bottom of the page is going to involve deductive reasoning. Now, before we get started, if you were a lawyer, okay, you would use deductive reasoning all the time. Okay, you might have a client and you're trying to find a case, where someone received 5-year sentence in prison, and you're trying to see how many years your client might receive in prison. So you're trying to draw logically certain conclusions from known facts. But in a geometry sense, it really starts with our conditional statement. And we have if P, then Q. And for right now, I want you to write this down. Let's say this. Let's say if you receive A's, B's, and C's at Westview, we'll just place 1W, then you can attend a four-year college. You can attend a four-year college. Now, generally speaking, this is true. If you receive all A, B's, and C's at Westview, then you are qualified to attend a four-year college. But let's dig a little bit deeper here. The term hypothesis is whatever follows your if. So the P in this problem, let's underline our P in red. The P is going to be you receive A's, B's, and C's at high school. So maybe let's write that in. You receive A's, B's, and C's in high school. Well, we can do the same thing for the then. On the then, it's known as Q, and so whatever follows then will be our Q, and that's going to be you can attend a four-year college. So in our problem, our conclusion was you can attend a four-year college. All right, now what we have to do with each of these statements is consider what's known as the truth value, meaning is our conditional statement, is this true or false? And at first, I said, hey, I think this is true, but let's dig a little bit deeper. When is this false? Well, I would like to think that if you score really low on the SATs, or maybe you don't even take the SATs, you may not be able to attend a four-year college. So if it's not, it needs to be true 100% of the time. If we can find out one example where it's false, then it makes the whole statement false. Even if it's true 99.999% of the time, it just takes out one counter example. So let's use our score low on the SATs. This is going to be called our counter example. And so that made this conditional statement false, which is what we have down here. So we're going to write score low on the SATs, and that would prove this false. For equivalent statements, draw an arrow down to the bottom. We're going to use that down near these. We're going to use the equivalent statements down where we have these snowflakes. So we'll do that last. But moving back up to our problem. So for our truth value, we found that our first conditional statement was false. Alright, next. The term converse. This is a very important term. I'm going to put a star by it. And what it says is if Q, then P. So what happened here is we flipped our hypothesis with our conclusion. So let's do that. We're going to say if you attend a four-year college, so if you attend a four-year college, then you receive all A's, B's, and C's at high school. And so again, we want to assess if this is a true statement or a false statement. And hopefully you can tell that this statement is also going to be false. Now when it's false, we need to give a counter example. So again, our counter example will prove our conditional statement false. So let's think about this. When is this not true? Well, what if you went to a junior college first? You know, you don't need to receive all A, B's, and C's to get into a junior college. So perhaps you went to a junior college for 2 years, and then you transferred to a four-year college. So that would be one counter example. Next, we have our biconditional statement, and we're going to focus on this on the following page. So for now, just know that it's P, if, or IFFQ. And IFF means if and only if, but again, we'll get into more of that on the next page. The inverse. The inverse now says that we have if not P, then not Q. So we have to write this out again, but this time we're going to include the not. So we're going to say if you did not receive A's, B's, and C's at Westview, then you did not attend a four-year college. So just like we've done before, we have to examine if this is a true or false statement. And once again, hopefully you can tell that this is going to be false. And again, we must give a counter example. So our counter, if you did not receive A, B's, and C's at Westview, then you did not attend a four-year college. Well, we just got done saying that you could attend a junior college and then transfer to a four-year college. So again, I'm going to use JC as my counter example. Next, for the contrapositive, if not Q, then not P. Guess what we have to do again? We have to write it out. This time we're going to flip our hypothesis with our conclusion. So if not, if you did not attend a four-year college, if you did not attend a four-year college, then you did not receive A's, B's, and C's at high school. once again, we have to examine whether or not this is going to be true or false. So if you did not attend a four-year college and you did not receive A, B's, and C's at high school, again, this is going to be false. And why? Well, let's think about it. If you did not attend a four-year college and you did not receive A, B's, and C's at Westview, not necessarily. Let's say that you joined the Army from high school, but you were a straight A student, all right? But you decided, you know what? I want to join the Army, the Marines, Navy. Maybe you received straight A's and you just chose not to go to a four-year college, or maybe you can't afford to go to a four-year college, and so you choose to go to a JC first to save money and then transfer. You get the idea. All right, next we're back to our equivalent statements. So here's what we want to say here. If today is Friday, then tomorrow is Saturday. Okay, well the if can also come second, and here's what I mean. I can say tomorrow is Saturday if today is Friday. Then I can also say that today is Friday implies tomorrow is Saturday. Now, after the word imply, let's think of imply. This is always going to mean then. So, today's Friday, then tomorrow is Saturday. So after the word imply will always come our conclusion. Next, they want us to rewrite the statement in if-then form. So what they're asking for us to do here, when we have this if-then form, they want us to write a conditional statement. That's what they're really asking us to do. So remember that a conditional statement is going to be if, and then we say P, which P is our hypothesis, then comes our conclusion, which is Q. Okay, so note that in this problem, the if comes second. So when we write our conditional statement, we need to write the if first. So I'm going to say if angle 1 is acute, then measure of angle 1 equals 82 degrees. Again, our hypothesis will follow the word if. So what follows the word if is angle 1 is acute. And remember that our conclusion will follow the word then. So we have measure of angle 1 equals 82 degrees. Next, we're going to consider the truth value, either true or false. And clearly, hopefully you can tell this is false. And why is it false? Well, our counter example, just because angle 1 is acute does not always mean that angle 1 will be 82 degrees. We could have measure of angle 1 be 16 degrees. We could have measure of angle 1 be 89 degrees. So there are many more degrees or many more measures of angle 1 other than 82 degrees. Write its converse in if-then form. So this is where we flip the hypothesis with conclusion. So we're going to say if, and this time I start with my conclusion, if the measure of angle 1 is 82 degrees, then angle 1 is acute. Well, in this case, this is going to be a true statement, always. So we had one false and one true. Next problem, x is equal to 5, implies, and remember the word implies means then. So when we write our if-then statement, we have to write if x is equal to 5 first, followed by then the absolute value of x is equal to 5. Our hypothesis is going to be the if part, so x is equal to 5, and our conclusion is going to be that the absolute value of x is equal to 5. Next we have our true false. Now let's not overthink this, because sometimes that leads to problems in geometry. Let's keep it simple. If x is 5, then the absolute value of 5 is 5. Yes, this is always going to be true. The absolute value of 5 is always 5, therefore this is true. However, now let's look at the converse. And on the converse, if the absolute value of x is equal to 5, then x is equal to 5. Now, this will be the case where this is going to be false. Okay, and why is it false? Well, isn't it true that the absolute value of negative 5 is also 5? So again, we had one true and one false. Now, when both are true, we can then write what's called a biconditional statement. Only if the conditional and converse statements are true. So let's take a look. Down below, we're told that each conditional statement is true. So they're already telling us that this part is true. They want us to write the converse next. If this converse is also true, then we have to write what's called a biconditional statement, since both are true. So let's flip this around and see if it's true. Again, we're told that this first conditional statement is true. Next, for the converse, if x plus 15 is equal to 20, then x is equal to 5. And this is always, or this is also going to be true as well. They're both true. So on the biconditional, we no longer use the word if and then. It's replaced with, we say x is equal to 5, if and only if, IFF, x plus 15 is equal to 20. And this is our biconditional statement. That's it. There's no if and then. It's replaced by IFF. Now, please understand, you can also say it the other way. You can start it off with x plus 15 equals 20, if and only if, IFF, x is equal to 5. So, more than one way to write your biconditional statement. Either way works. Next, we have, if two lines are skewed and they are non-coplanar, let's write the converse. Now remember again that this was given if the first statement is true. Now, please don't start it with if they, because if they is vague, we're not sure what they refer to. So we're going to change this to if lines are non-coplanar, then they are skewed. So we have to determine if this is true or false. If lines are non-coplanar, then they are skewed. Yes, this is always going to be true. So our biconditional is going to say lines are skewed if and only if they are non-coplanar. To the last problem. We may not be familiar with an isosceles triangle, so let's draw one. And that's where two sides of a triangle are each congruent. Alright, this is known as an isosceles triangle. Well, in an equilateral triangle, all three sides are the same. Okay, this is known as an equilateral. But understand that since at least two sides are each congruent, this is also in isosceles. It's in isosceles and equilateral triangle. So on our converse, and again, this statement is true. It was given to us, the first conditional statement. Let's write the converse. If at least two sides of a triangle are congruent, then it is isosceles. And let's examine the truth value of that. If at least two sides of a triangle is congruent, then it is isosceles. Yes, that's true as well. So since each are true, I can write my biconditional statement. And we're going to say a triangle is isosceles if and only if at at least two sides are congruent. Thanks for joining us. See you next time.